year. Okay, so and he's saying that he won't probably do it next year again because it's like mad rush. Python interpreter is not a small piece, right? You have to implement so many different pieces. Okay. So so let me introduce myself. I'm Anand. Mostly work in Python. So I really recently attended an online course called Programming Languages. So it's a course from Brown University. It's offered online in 2012. So the course project was to implement a Python interpreter. The whole Python interpreter got implemented. Okay. So when I saw that thing, I was really excited because it's so challenging project to work on. And like, I mean, one thing is we learn the tools to implement interpreters, and you're going to implement Python interpreter. And since Python is my favorite language, I thought it's a good opportunity to go and do that. So we did the course. The course is like over a span of 3 months, and the 2 months project is to implement Python interpreter. So I'm going to show about things that I've learned during the course and how Python interpreter how my Python interpreter works. And then feel free to stop me anywhere in the middle and take questions, to ask questions. So the design is, the first I've implemented a core language which is very small. And then the Python concepts are translated into that small core language. So I'll actually show you why it's useful. That's a technique that's core of the design. If you see, it has 3 different phases: parsing, desugaring, and interpretation. Do you know what a desugaring is? Okay. Do you know what a syntactic sugar means? Nobody heard of this term before? Syntactic sugar is something which is not really a new feature as such, but it makes you easy to write code. Okay, it's kind of it makes humans. It makes nice for humans. It feels sweet to humans. Okay, it's called syntactic sugar. So this part is the reverse of that. Okay, so you have a language feature. You're doing the reverse of that. Okay, for example, you have a for loop. Okay, it's a glorified while loop, right? So desugaring actually takes the Python language and converts it to core language. So in the interpreter, in this jargon, it's called the surface language and the core language. So the surface language is what we are saying, that's Python here. And the core language is, so as part of the implementation, I have designed a small core language, and everything else is translated to the core language.
So the core language is defined in this course?
No.
I have to desugar it?
I have to design a core language myself and then desugar all of it. Okay. So the first phase is parsing. Okay, that's not so hard part. Okay, that's not really as hard as implementing an interpreter. Okay, so what we did is we used the CPython parser. So what we do is we take the Python code and then give it to CPython parser, and then get the parse tree and then convert it to JSON and then load it back in my implementation and then use it. Okay, so the parsing part we're really not implemented. Just, well, we call it cheating because we're just reusing the Python implementation. Okay, so this is implementation of Python 3.2. So we need to have Python 3.2 already running, already available on the machine, because we take the code, give it to Python 3, that gives us back the syntax tree as a JSON format, and we read it and then implement it. Okay. The interpreter is implemented in a language called Racket, which is a dialect of Lisp on Scheme. So I'll show you how it feels like. Okay.
Sorry,
yeah.
So this interpreter, no optimization, there's no huge step of things.
Not at all. Okay.
The
so
most difficult portion of
no, that's not the difficult portion. The difficult portion is to get the semantics right. Okay. Once you get that, okay, then you can actually go step by step and figure out which needs to optimize. Okay. So optimize. So here, if you look at someone like me who has not dreamt of implementing something like this before, okay, ability to implement a Python interpreter itself is a great achievement. Okay. So I'm really not. This is more an academic project than real production system. Okay. So once I know how to implement an interpreter, then I can actually scrap this and then do a real job. Okay. In fact, I've scrapped my implementation 5 times to actually get this right. Okay. So that's the whole design. Okay. So I'm going to show you each of the phases. Parsing is we are not done. So we'll show you what, I'll show you how the core language is, okay. So you see this is the core language written in Racket. So let's not get into the syntax of this, okay. So it's basically these are the, you can say the keywords in the language, okay. So you have undefined, that says it's an undefined value. None, that's translates to none value in Python. Number and string. Sequence, the sequence of, so CXP is an expression. So one expression can be any of this. So that's how a language is defined, core language is defined. So if you see, there are hardly like 10 constructs in the language, and they're very, very simple. If you see, I'll show you, explain each one of them. So the primitive values, you have undefined, none, number, and string. And then the variable binding and assignment. So see, let, it actually binds a value and evaluates a piece of code. Let's see what let is. So let ID, value, and body. So it says ID equal value inside this body. So it's a let x equal 1, x plus, print x plus 1. Okay, so the binding of ID is available only in that scope. Okay, that's one concept. And then inside that you can reassign something.
What would ID be?
ID is a string, it's a symbol. That symbol is just a string. That's like an identifier. Not, it can't have spaces and all that. So, see, ID is we are referring back to already defined variable. So we just say print x, right? But in the core language, it's get me variable x. Okay, that's how it should.
Let's say if I was implementing the same thing in a familiar language like C, right?
Okay.
So what would these guys be like? It's a struct or something like that?
I mean, you can do it in different ways. Okay. For example, so what do you say? If you're doing it in C, you actually define constants and say that what is each construct. Yeah, each probably could become a struct.
Okay.
Yeah.
Okay.
So now, so if you see, on the whole, it has primitive values, ways of binding variables and assigning, and then functions. cfunc creates a function, capp applies a function. If condition, ways of handling errors, error and if error, what the error happens, and sometimes, these are single expressions, right? Sometimes you won't have a block of code. You need to have a sequence. Okay, sequence can say list of expressions. Okay, but list of expressions is hard to handle than saying that expression 1 and expression 2. Right? So, C sequence is a sequence of expressions that contains 2 expressions. Okay, so if you want to have a list, you can actually cascade them. Right? So, but the core language want to see make it as simple as possible so that this implementation is not hard. Okay. So if you see, it's not too hard to implement this language, right? I mean, do you see what all things the core language is providing? So I'll show you some of the examples, but they basically have the primitive types. We have creating function, we have applying a function, and if condition. So I have C global here because it looks just like C let, but it binds to a global variable. That's because for the Python semantics. Okay. So I'll show you some examples and it will be clear how this thing works. So, first I implemented an interpreter for this core language. The core language is as simple as possible. For example, that if in the core language, it takes a test, what to do if it's true, what to do if it's false. So the test, it doesn't know anything about Boolean values or anything. So it considers one as true, everything else as false. Okay. Now it's a job of the desugaring process to convert it appropriately. So the whole complexity is moved out of the core language into some steps of translation. Okay, which is not very hard. Okay, so once you implement this and make sure the semantics are right, everything else is just a transformation. So let's say look at an example in the core language. So if you see here, clat square. Square is a function. Function taking one argument. It's a list of. So it's written in Racket. Okay. So don't get too confused about the syntax. So it's a Lisp-like thing. So when you want to say plus xy, you say bracket plus xy. So in Lisp, it's actually a nice language. Okay, it's very simple language. Okay, it doesn't have any syntax. What do you mean doesn't have any syntax. You write the syntax tree yourself. Okay. So you say, when you say plus, you want to add two numbers. Okay, you say plus bracket plus xy. Okay, this is a node. Apply plus to x and y. Okay, that's so you actually write the syntax tree yourself in Lisp. If you actually see, okay, just basically specifying here. Let square be this value and bind this square. So bind this variable to this value and then execute this piece of code. Okay, so let's see what's binding. It's binding to a function. So cfunc. That's how the syntax have defined. Takes, so this has two parts. One is list of arguments and the body. So list of arguments is it takes one argument x and then apply find id star. Okay, the hash, the code thing is racket we are saying it's a symbol. Symbols are like lists, but if you know Ruby, then you know what a symbol is. Like you say colon something in Ruby. So it finds function star and applies and calls that with two arguments x, value of x and value of x. Okay, and then inside that you basically apply print with square of this. Okay, so this is how the core language is. Okay, but it's hard to actually make sense. So I actually return a function to ready print that. So if ready print, it becomes this. Okay, so this is this is more like a JavaScript like syntax. Let square equal to function x, and you don't have any return in the core language. Core language, you evaluate function, the last value is what is given back. More like Ruby kind of thing. You don't do a return. The last evaluated value is taken. And then let's square equal to this function, and then execute this piece of code. Print square of 42. Okay, it computes square of 42 and then prints it back. So do you understand how the core language is working? Okay. I mean, this is how it's represented internally, but this is how I print it.
Can you just remind what CID was?
Okay, CID. So when you say x something, okay, that's we say when x is a variable, okay, but the core language you have to say take the value, look up variable x and give me that value. Okay, so I just print it as x because we all know that in all common language that's how we write it. Okay, but in the core language, I can actually say that go and find the value of variable x. That's CID. CID is basically get me value of that identifier. Okay, so CApp is apply a function. Even in multiplication is a function in the core language. Okay, so in my core language, there is no differentiation between there are no operators as such. Everything is a function. So it's important to make core language simple because once you implement interpreter, everything else is additional. It makes the implementation very easy. Okay. So these are data types that I have in the core language. So what I've shown earlier is the syntax of the core language. And the core language, that's a code, and this is a data. So I have C print value. So this is a racket syntax, but let's not get much into syntax. So I have three different types. Prim val, that's primitive value, object, and an answer. So what's a prim val? It's primitive types in the language. I have undefined, none, number, string, vector, and a function. Okay. So racket actually a family of languages. So this is a language called PLA type. That means it's a type language. So every time you do, you actually define what type it is. So for example, pnum actually has one. It's like a structure, and is of value number. So it's like a defined type is like a union of these structures. One of these. Okay. So pnum can be undefined or null, or p structure num with n as number, a string with s as string, vector of elements. It's a vector of C object this type, or it's a function taking list of C object argument and giving back a C answer. Okay, what's an object? Well, object has primitive value, a class, and a dictionary of key value pairs. That's how I define an object. Okay, forget about this.
So you simplified the definition of an object.
Yeah, so the core language doesn't know anything about classes, inheritance, or anything. Okay, so object is something which has primitive value, a class, and a key value pairs. Okay. And what's an answer? Answer could be an object or an error. So core language doesn't have exceptions. I mean, it has kind of handling errors. Okay, so when you do so take an expression, evaluate it, it gives you back. You should give back something, right? So it gives back an answer. Answer could be an object or an error. Okay, one of these two. Okay, so what do you do if it's an error? What do you do if it's an object? So that the interpreter takes care of. Okay.
What is that O self?
Yeah.
O self.
Sorry.
The
O self.
Yeah.
Okay. So now, how do you create the first object? Okay. So I little bit skip that because it gets too complicated to explain that at this point. Okay. So since you asked, let me explain. So I have defined object type. Okay. How do I? So to create an object, I need to have an object. Okay. So how do you create the first root object? Okay. So that's a workaround to do that. Okay. So self is actually an object. Okay. And then I create an object so I create so then I create an object and pass this as a class. So I create a first class by type. In Python there is a type class. Okay. So the class of that is self. Okay. So whenever I see class as self, then I say class is itself. So that's how I implement
this. This self has nothing to do with the self of that in Python.
No, this is not self in Python. Okay. This basically how do you bootstrap objects now? Since you have objects defined in terms of object, how do you create the first object? To create an object, you need to have an object. So it's not possible to create an object at all. Okay. To overcome that, I've defined something which. Okay. So this is how the language is. Okay. So what the interpreter does is takes a C expression, that's the code that we have defined. Okay. So if we go back, so this is a C expression. Okay, that's a code. Takes code and produces some data. That's what the interpreter does. So what it gives back is a error, a answer, C answer. Basically, the conventions are used is C for core language. When say C prime value P, the P is used here. The C object, the O is used here. If it's C answer, then A is uses prefix just to make some convention that we use in the class. Okay. So is that clear? Like what core language and what is it doing? Okay. So yeah.
On the last slide, plus and multiplication symbol, that was actually function here.
Yes.
So the square is a function and this plus
Yeah.
symbol or whatever
Yeah.
the start symbol
Yeah.
is a function.
Yeah.
And the next one, function becomes a primitive type.
Where
On the next slide, here the operators become function, and
Okay.
here the functions are actually primitive values. So everything, how the primitive values
No,
and
so
operators
here-
are different.
we're talking about code here. Okay. This is code. So then you should look at CXP here. Okay. So it's this. Okay. So what I've shown is the values there.
No, I understand it like operators are also a function.
Yes.
And then on the next slide, the functions are the two primitive types. The int string are primitive types, and the function also is a primitive type. How it is the operators are different.
No,
Operators
so-
are actually
So,
functions.
so let's not see it as a operator. Okay. See like it's calling see it as
Multiple
becomes
function.
That's a function. Okay. Just that I named it as car just because that's makes more sense. Okay. Because inside my core language, in implementation, what I do is define a function, multiply, and then say call this with add this, install this function as start. Okay. So whenever you see this, you get.
That means there is no operator, that actually is a function.
That's just a function. Okay. Yeah. See, I'm saying that. So just like I'm saying that get me value of x and say get me value of star, and then apply that. So C app takes three things. C app is actually basically defining code. It's saying that C app actually has three parameters. What is the function to apply and two arguments. So first argument is the function itself. So I'm saying get me function by name star. Okay. So now, if you see, so C error is something what it does to do kind of implement some primitive kind of exception handling. It's not the exception handling that we see in Python, but very primitive. I'll show an example of that when I go and look at dictionary. So is it clear like what the core language is doing? Okay. So I'll actually show. Just have open one. Can you see this? Sorry, this is not This is an external interpreter. Okay, so what it does is it takes an expression. I'll talk about environment and stored later. Okay, but if you take a number, then you convert it to object with the primitive value p number. Okay, with string they convert to primitive value p number. Okay, if you sequence, then you first evaluate ur and then evaluate p2. Okay, so it's like this is how the implementation goes. Okay, so I'll not get into the implementation details right now because I want to show desugaring. Because if I get into the implementation details, it kind of gets too deep. Because I want to show the basic idea of how it's implemented. Okay, then we'll come back to this if required. So that's what we have, the core language and the core data type, the core data types. Now, next what we do is desugaring. Take Python code, okay, and then convert it into the core language. So how do you do that? So there is a desugar function which takes an expression, Python expression. That represents the expression in Python, and then converts it into a C expression. That's the core language expression. So how does it work? So you take a pi number, that's damn simple. Just convert it into a C number. Pi string, just convert to C string. Okay. What if you have a pi if? If has a condition, then part and else part. Okay. So now the Python kern can actually be number, can be a list, can be a string, can be anything, right? But my core language doesn't understand all these things. Core language, if only works with one is true, everything else is false. Right? So when I desugar, what I need to do is it basically makes pi if into C if, and then it takes the condition and then applies a function. It converts into Boolean value. So I define a function underscore bool, and then it gets desugared. So I desugar each one of them recursively and then call it. Okay. So let's actually see how. So this is one simple desugaring step that I have in my implementation. Okay. So I'll show you how this thing works. So if you take Python code like this, it gets translated to this. If x less than 0, then y equal to minus x, plus y equal to x. Okay. Now, I'm not showing the core language as such. I'm doing a prediction of the core language because that's easy to understand. So if x is less than 0, this translates. So if under condition this becomes right. So less than 0 is actually function, known as a function in the core language. Less than x comma 0. That can give any value, or let's say if x, right, or if x is upper. So I can actually put any Python expression here. That need not be a Boolean value. So because Python considers empty list as false and regular list as true and all that. Okay. It has different semantics for what is true. Okay. I don't want to overload my core language with all this information. That has to be done somewhere independent of the core language. So what I do is I implement a function called underscore bool. So my implementation has a lot of built-in functions connected to the language. So that takes a value and tells you and gives back something which the core language understands. So it basically gives 1 or 0. Okay. So if this gives 1, then this is executed, otherwise this is executed. And if you see minus x here, okay, what is minus x? That's a, I implement that. So I implement it as an underscore user. That's a, I implemented a function to handle that case. Okay. So this is how the desugaring works. Any questions about the desugaring? Okay. So, but you see, the core, the key thing to understand here is when you're implementing something like an interpreter, which is a pretty big project, right? Because it has, the language has different semantics, okay? So you shouldn't get overwhelmed with all those details. So implement a core language which suits this implementation and then translate it, do shearing to translate it. So let me show you some more desugaring things, okay? So there's one nice thing in desugaring. Sometimes you don't desugar into the core language, you desugar to the same language. So we have core language and surface language, that's the terminology used. Okay. So the Python language what you're talking is the surface language, and the core language is what I've seen before. Okay. Now, there's an idea called macros. What are macros? You take a piece of code and translate it into something else in the same language. For example, for loop is actually a glorified while loop. say, if you see Python for I in range 10, print I, this can be translated into underscore id is iter of this. That gives me an iterator in Python, while true. So, how many of you know what iterators are in Python? Okay, so let me explain that first before I get into this. Okay, so Python iterators are, we'll just give a quick demo of what an iterator is. So when you actually say this is Python 3. Okay, this is I'm doing a iteration over a list here, or I can do an iteration over a tuple, or I can do an iteration over a string. Right? So all of them are working exactly the same way. How is this possible? Because there is something called iteration protocol in Python. So when you call an object that supports that protocol, it is an iterator. What is next? That's an iterator object. It's the next of I, next of x, that gives next value. Then call next again, that gives the next value. It's the next, that gives next value. When you reach the end of it, it will raise an exception called stop iteration. It's a protocol. There are different kinds of objects that support this protocol. So the list supports that, tuple supports that, string supports that, dictionary supports that. So there's so many objects which support that protocol. So what for does is it actually uses this protocol to implement it. So what happens is when you actually do for I in range 10, this is what Python does internally. First creates an iterator of that, what are you passing here, and then in a while loop it tries to get the next value from the iterator. If there are no more elements, that means if it tries a stop iteration, then you come out of the while loop, and then the body comes here. Okay, it's basically for loop. We're translating for loop into something in the same language. It's called a macro. Okay, it's a technique used because some of the language features are actually duplicate of what's already there. So for example, you can do the same thing in 3 different ways. Not really much difference, okay? There's no point overloading your implementation with all those fancy things. You should just solve this problem as early as possible. You shouldn't reach to the core language because the complexity, so you have to cut down the complexity as much as possible. Right? So the core language is very simple, and then you have this desugaring step. And then sometimes you don't want to even do the desugaring. You want to convert into the same language and then apply the desugaring to that. Basically, if you want to desugar this, you don't desugar this. You convert this into the core language, into the same language, like this, and then desugar this. It's called a macro. So you write a macro for this and then desugar the whole thing. Because you already know how to desugar a while loop, so problem solved. Is that, you got the idea? It's a very powerful idea. Okay. In some of the programming languages, you actually have macro support in the language itself. You can actually define macros in the language. For example, in bracket, you can actually define that. For example, if your language doesn't have a for loop, you can write a define macro in the language to actually define for loop yourself.
So if in case of list comprehensions also same thing applies, is it? But I think that you, something else will be.
No, I'll actually show how my list comprehension works. Okay. Then you actually see because that's again can be desugared. That can be put as a macro. So let me show you what it really means. Okay. So that's what. So I've shown you what I can do for okay. Let me actually show what the real implementation looks like. Okay. When I'm desugar infer, what I do is I don't desugar. I create a macro, call a macro for, and pass all the arguments that I get. That gives me another code in the another Python code using while loop, and then I desugar that. So instead of implementing desugaring for, what I do is I first translate for loop into while loop like this, and then desugar this part. Okay. So that's not too difficult because we already know how to handle the while loop. For example, now if I don't do desugaring, so if I don't write a macro, then I have to worry about how do I implement break for while, how do I implement continue, how do I implement Python has an else for while and for loops. Okay, so I have to again worry about all these details. Okay, Now, since I'm translating for to a while loop, there's no problem. Just translate once and you forget about it. Okay, you write a macro and problem solve. Okay, so the implementation actually looks like this. What it does is it basically the same thing written in bracket there. Okay, so what I'm doing is here let id iter equal to iter of that, iter of yeah. So it's basically calling the iter function, and then while true, then run these two pieces of code, code next and body. What's code next? I've defined that in the beginning. Okay, with the try and except. Okay, assign whatever target is given here to next of that. So it's basically just this piece. Okay, so this piece I've written as a different block. Okay, so this is code next in the slide, and this is the body of the function, body of the for loop. So this is I is the target there. Okay, so if you see, it gets a target that's for I. So I is a target for I in range 10. So range 10 is iter. Okay, print I, that's a body, or else we don't have, or else in our example. So what I do is basically convert it into while loop. So this is the implementation of what I've shown in the previous slide. Okay, so this is a complete implementation of for loop in my interview. Okay, see, so it's not too complicated, right? So I mean, there are many different pieces, but you cut down the complexity by doing these are the techniques that we learned in the class and implemented in our interview. So now let me show you some deissuing examples. So the core of the interpreter is actually doing the deissuing. So let's see if I have a function absolute like this, absolute x is less than 0, return minus x, else return x. Okay, it gets desugared into such a big piece of code. Okay, let me actually tell you what this really means. Okay, so now in Python, function can have multiple arguments, default arguments, keyword arguments, all such nonsense things. Okay, and my core language doesn't even care about any of this. Okay, now how do I handle that complexity? Okay, so what it does is it creates one core language function and then wraps that into a function object. I'll see what it means later. Okay, don't worry about the stack frame. That's just a hack implemented just to implement. Python has something called function called locals that gives you local variables. Okay, so I need to find out what are the current local variables. So I've actually added the stack frame. What it does is it takes the current local variables at this point and then saves, put it on the stack so that I can actually implement locals. This is a bit of hack. Don't worry about that piece, but look at the rest of it. Okay. Okay, now the key part is we have already seen how if is desugared to. If x less than 0, we can underscore bool less than x0. Okay. But now what is this raise and except that I haven't talked about in the core language? Okay. So in the core language, there is something called if C error and C if error. Okay. C error is raise. Okay. C error takes two parameters. Okay. It takes a label, that's a string, and then a value. That could be anything. Okay. So the core language is deliberately made as simple as possible. Error takes label and an object. So raise, return, and this. Okay. And then except. Okay. So except says except error of this label and as this value. So the value what we raise actually comes as this value, and then do this piece of code. Execute this piece of code. There is no error. Okay. I mean yeah, there is no error, then do this. Okay, so that's how the core language is specific. Now, you see, actually, implementing return is actually pretty hard. Why is implementing return hard? You're executing a piece of code, and somewhere in the middle you want to abort the function that says, here is the result. Right? You see, look at our core language. It has expressions and then sequence of expressions. Execute this one and this one. Okay. Now, how do I say do return? Right? It's very complicated. So you have a sequential control flow and suddenly you want to say I'm done and then just come out of the function. Okay, that's pretty okay. So what I do is I implemented return as an exception. Okay. So what's the exception? Whenever exception comes, already core language has support for cryptography errors. So I will put return as an error. Whenever I say return something, I say raise return there. Okay, so I have a label for each type, right? I have a label for each error. So I say the label is written. So when I define a function, I get distributed like this. So let's actually see what's happening. I have this whole thing in try and except. Okay, if this returns anything, okay, if it raises any return error, then you give the return value. Otherwise, give none. That's how Python functions work, right? If you don't return anything, it gives none back. If they return something, then that return value comes to you. Okay, but if there is any other kind of error, that just comes out of the function as an error itself. Is it clear or too complicated?
What is the difference between the front end raise and the code language raise?
Yeah.
So,
because the front end raise is very expensive, so you don't want to use it.
no, so
throughout
let's not.
the language.
There's no performance issues here.
Okay, so you just forget about that.
This is not the you're saying that in Python C implementation it is expensive.
Yeah.
I'm not talking about Python code language, C language at all.
No,
Okay.
what is the difference between front end raise and this raise?
So this is basically a pretty print of the code language. Okay, I don't have any language actually looks like this. Okay. So if I print it like C func and all that, it's too difficult to understand. Okay. In fact, even for me it's difficult to understand. When I'm implementing it, I want to see how it's getting distributed to. How do I see it? If I just print it, it's like doesn't make any sense. Okay. So I wrote a function to pretty print the code language. So it actually prints this to me.
So it's the same between front end.
It's a code language. It's a pretty
language.
code language.
Code language raise and this raise is exactly the same.
Exactly the same. The code language has C error. That's what we call raise because it's easy for me to actually make sense of it. Then okay.
You mentioned something about the labels.
Yeah.
It's a special type of phrase.
No, so it can take any number, any name. Okay. So code language supports errors like this. Okay. So let me go back to the code language syntax and then show you how what it. Okay. So this is my code language. That's all. It's my code language. So have a C error here. Okay. Takes a label and an error. Error is again a piece of code. That could be any piece of code. Okay. And then C error. Okay. Takes a body. So execute this body. Okay. And then E label. That means if this body raises any error of this label, okay, then bind that value of that error to this name and execute this piece of code. Otherwise, execute the other piece of code. It's like an if condition. It's almost like an if, right? If I'm saying if test is true, execute this, otherwise execute this. This is a slightly different form of if.
So the label here is return. The label there.
Yeah, the label is what I decide to use there, but the code language doesn't say anything about those labels. Right? Code language says that you have a label and then you are free to use whatever label you want. Okay, and I have been written using this feature in the code language. Okay, so now raise this label is written. I'm saying that if there is any error of this label, then get that value as written value and then and say written value. So in the code language, whatever the last expression evaluated is the value of the function. Right? So the written value is what gets written. So now,
But still, kind of worried that. So if you use the front end language, raise is associated with all sorts of things like stack, raise.
no. So let's not. So let's call this error. Don't call it raise.
Okay.
So this is just a pretty print of what I have.
Okay.
It's not really any language.
Oh, sure.
Right? The code language I call it C error. If you really want to say, you should say C error.
Okay, sure.
And this is not try except it's C if error.
Okay.
I just printed it because it's easy to read for me.
Okay, sure.
Now, so that's how the functions are implemented. Now, it's how this while loop gets distributed. So now, I don't have any while loops in my code language, right? Did you see any loops in the code language? Code language has functions, if condition, and the primitive values, and if error. Now, how do you implement a loop in the? You want to take a break or something?
Yeah, some samosa and coffee. You can take a quick 10-minute break.
Yeah, so we can just take some 5-minute break and then. Yeah, then we just think about how to implement while loop. in a language which doesn't have any loop support. Okay.
Recursion.
We'll see. Okay. So let's take a small 5-10 minutes break and then we'll come back.